Okay, we're going to talk about completing the square today. And completing the square basically is taking a quadratic term, which is your x squared, a linear term, which is just your x, and figuring out what we would need to add to that to create a perfect square trinomial, which we can then factor. Okay, so that's basically the whole premise between completing the square. So if a quadratic equation does not have a perfect square, it may be possible to transform it into one that does by a method called completing the square. So we're going to study these two squares below. So here I have a perfect square, x plus 4 squared, and when I multiply it out, I get x squared plus 8x plus 16. Okay, this was squared, there's my x squared, 4 was squared, there's my 16, and x times 4 times 2 gave me my 8x. Okay, if I take this middle term, this x, and I divide it in half, I get 4, okay, which is what I have right there. And then I square it, I get 16. So what I can do is I can take whatever the coefficient of my linear term is, divide it in half and square it, and that will tell me what I need to add. The number that I have before I square it is what's going to go in the parentheses. Okay, so let's look at this one. This time I have x minus 5 squared equals x squared minus 10x plus 25. If I take the negative 10 and I divide it by 2, 10 divided by 2 is 5, and I square it, it gives me the 25. Negative 5 is what goes here. Okay, so here's a little formula to help you. X plus a squared, and this is what you're going to start with this. Excuse me. You're going to start with this, and you're going to figure out what this needs to be, and then you're going to write this. Okay, but this is the formula you're going to use. So in each case, notice that the coefficient of x squared is 1, and the constant term is the square of half the coefficient of x. So basically what that means is the number in front of my x squared is 1. Okay, if it's not 1, we have to do something. Okay, and that the square, okay, which is the constant, is the square of half the coefficient of x. So whatever this number is, we divide it in half and we square it, and that gives us the number on the outside. Okay, so here are some basic steps to follow. When you're given x squared plus bx plus whatever, okay, you're going to find the coefficient of x. In this case, it's b. You're going to divide it by 2, and you're going to square it. That's what you're going to add to the end, okay? That'll be your constant. And what you have before you squared it is what goes in the parentheses. So let's do an example so that hopefully this makes a little more sense. Okay, I want to complete the square. I want to write this so that I have a perfect square trinomial. So I'm going to take 14, that's my b, and I'm going to divide it by 2, which is going to give me 7. And then I'm going to square 7, which is going to give me 49. So if I write this, I have x squared plus 14x plus 49. And that would be equal to x plus 7 squared. Okay, whatever this was before I squared is what goes in the parentheses. If I look at this one, I have 9, so let's write it over here instead. So I have b is equal to negative 9. So negative 9 divided by 2 becomes negative 9 halves. How's that? And if I square that, I end up with 81 over 4. Okay, so I'm going to write this x squared minus 9x plus 81 over 4. And that's going to be equal to x, and then I just take whatever I had before I squared it, x minus 9 over 2 squared. And you're looking at this going, what? Okay, we don't worry about this so much. We're more concerned with this, and then we're going to end up solving for x. Okay, so let's look at our next example. Okay. So here we have an equation that we want to solve by completing the square. Okay, this is not a perfect square trinomial, but we want to create one so that we can get rid of this x squared. So here's what I'm going to do. X squared minus 3x plus something. I'm going to fill in that blank. I added 18 to both sides. So what I did is I just moved the 18 to the other side. Okay, what I do to one side, I have to do the other. So whatever I add here, I have to add here as well. Okay, so my b is 3. So 3 divided by 2 is negative 3 halves. And if I square that, I get 9 over 4. So I'm going to add 9 over 4 to both sides. Okay, this is now a perfect square trinomial. And the term that goes inside the parentheses is the negative 3/2. It's whatever I had before I squared it. So minus 3/2 squared. So that's that side. This side I need to add. So I need to change 18 to number over 4. So that's going to be 72 over 4 plus 9 over 4, which is equal to 81 over 4, which looks lovely. Okay. So this is what I have. My perfect square is equal to this. And thankfully, those are both perfect squares because I'm going to take the square root of both sides. So what I get is I get x minus 3/2 is equal to plus or minus 9/4. No, it's not. 9/2. Okay. Two answers, so that means I need two equations. So I'm going to have x minus 3/2 equals 9/2, and x minus 3/2 equals negative 9/2. Don't change anything to mixed numbers. Just keep it the way it is. It's going to be easy, you'll see. So if I add 3/2 to both sides, I end up with x is equal to 12 over 2, which is 6. Okay, here I'm going to add 3/2, and I get x is equal to negative 6 over 2, which is negative 3. So my answers then are 6 and negative 3. And if I plug them in, let's plug in 6. 36 minus 18 is 18, minus 18 is 0. Okay, so 6 is good. If I plug in negative 3, I have negative 3 squared, which is 9, minus 3 times negative 3, which is positive 9. So 9 plus 9 is 18, minus 18 is 0. Okay, so that works well. Okay, this is a bunch of steps, but once you get the hang of it, it's actually pretty easy. And it's a real quick way to solve something that you couldn't normally factor easily. All right, so let's look at this one. It says solve 5x squared plus 8x plus 1 equals 0 by completing the square. Give irrational roots in simplest form. So we might have radicals in our answers, but here's what we need to look at. When we talked about these steps, it only works when the coefficient of your x squared term is 1. So what I need to do is I need to get rid of that 5. And the way we get rid of the 5 is we just divide everything by 5. So that's going to give me x squared plus 8/5 x plus 1/5 equals 0. Okay, I'm then going to move this to the other side. So I'm going to have x squared plus 8/5 x plus whatever, and it's always plus, equals negative 1/5 plus whatever. Okay, and these two whatevers are the same. All right. So I need to figure out what goes here. So what I do is I take my b, my coefficient, and I need to divide this by 2. Well, dividing by 2 is the same as multiplying by 1/2. So that's going to give me 8 over 10, which is going to be 4/5. Okay, I then need to square 4/5, which is going to give me 16 over 25. So 16 over 25 and 16 over 25. Okay, and don't let the fractions make it harder. They're actually easier because you're always going to end up with the common denominator pretty easily. All right, so this then is a perfect square trinomial. So what it factors to is x. It's going to be plus, and it's whatever I had before I squared it. So x plus 4/5 squared. Now these I need to add. Okay, so my common denominator is going to be 25. So 1/5 is the same as 5/25. So I have negative 5/25 plus 16/25, which is going to give me 11/25. Now, fortunately, the 25 is a perfect square, so we won't have a radical in the denominator, but 11 is not a perfect square. So we're going to end up with a radical. All right, so we have x plus 4/5 equals, these are positive, so I'm going to have a plus or minus, and it's going to be the square root of 11 over 5. So I can't really add or subtract a radical. So what we're going to have for our answer is going to have a radical in it. So there's two ways I can write my answer. The first way is I can just take what I have here, and I'm going to subtract 4/5 on both sides. So if I were to subtract 4/5, I would have negative 4 plus square root of 11 all over 5. Okay, because they have a common denominator, so it'd just be negative 4 plus or minus. Okay, so there's one way to do it. I can just write it as a single fraction with the plus or minus inside it. Or I could write my two equations, x plus 4/5 equals square root of 11/5, and x plus 4/5 equals negative square root of 11/5. So I would have x is equal to negative 4 plus square root of 11/5, and x is equal to negative 4 minus the square root of 11/5. Okay, so two different ways I can write it. Usually when we have the radical, it's easier just to write it this way. Okay, as long as it's like this and you just equal to plus or minus. Okay, so either one of these is correct. All right, so let's look at our proof. Solve by completing the square and check by factoring. Now they've already moved this one over for us, okay? So we need to figure out what we're going to add to this side to make a perfect square. So if I take negative 6 and I divide it in half, I get negative 3. And negative 3 squared is equal to 9. So I'm going to add 9 to both sides. So this becomes x minus 3, because I had a minus 3 before I squared it, equal to 1, because negative 8 plus 9 is 1. So when I take the square root of both sides, I get x minus 3 equals plus or minus 1. So x minus 3 equals 1, and x minus 3 equals negative 1. So x is equal to negative 2, and x is equal to positive 2. No, x is not equal to negative 2. X is equal to positive 4. Positive 4 and positive 2. If I plug them in, 4 would be 16 minus 24 would be negative 8. And if I do 2, I'd have 4 minus 12, which is negative 8. So they both work. So we should technically write it like this. Okay, this one, I need to get rid of the 6. So I'm just going to divide everything by the 6. Okay, even if this is 0, divide it by 6 so that you're in the habit of dividing everything by 6. So that's going to give me n squared minus, and I can simplify this to 5 over 3, n plus 2/3 equals 0. So n squared minus 5/3 n plus something is going to equal negative 2/3 plus something. So I have negative 5/3 as my b. I'm going to multiply that by 1/2 because that's the same as dividing it by 2. So it gives me negative 5 over 6. And when I square that, I get 25 over 36. Okay, so 25 over 36 is what I'm adding on both sides. When I factor this, though, it becomes n minus 5/6. That's whatever I had before I squared it, squared, equal to negative 2/3 is the same as negative 24 over 36. So negative 24 over 36 plus 25 over 36 just gives me 1 over 36. Okay, and 36 is a perfect square. Thank goodness. So I have n minus 5/6 equals plus or minus 1/6. Okay, same denominator, so it's going to be easy. So n minus 5/6 equals 1/6. N minus 5/6 equals negative 1/6. So n is equal to 6 over 6, which is 1. Or n is equal to 4 over 6, which is 2/3. So I have 2/3 and 1. And if I plug them back in, it'll work. So 6 minus 10 is negative 4 plus 4 is 0. So that's the 1. If I plug in the 2/3, 2/3 squared is 4 over 9. So 4 over 9 times 6 is going to give me 6 over 3, which is 2. So 2 minus 20 over 3. So let's do these all with the same denominator. That'll be easier. So if I take 2/3 and I square it, let me erase these 6's here. 2/3 and I square it, that's going to give me 4 over 9. And 4 over 9 times 6 is going to give me, what did I say it was going to give me? That'll give me 2, that'll give me 3, 8 over 3. So I'm going to write this as 8 over 3. And this one would be 20 over 3. And 4 would be 12 over 3. So 8 over 3, 8 thirds plus 12 thirds is 20 thirds, minus 20 thirds is 0. So both of those numbers work. Even though it's kind of a pain in the butt to check the fractions, you should check them anyway, because every once in a while you're going to get one that just doesn't work. Okay, so that is completing the square.